Okay, chapter 1, the chemical world. So it's summer. Most people are like, having fun, relaxing, going to the beach and stuff, and we're here studying chemistry. But we'll talk about sand to start off with. So you go to the beach, and the sand gets everywhere, doesn't it? It sticks to everything, right? And it's really annoying. Why does it stick to everything? Well, the sand particles are very small, right? And so that happens. Sand is an ordinary type of matter. It's composed of tiny particles called atoms. Atoms are mind-bogglingly small. Just as an example, a single grain of sand, little tiny grain of sand, has more atoms in it than there are grains of sand on the biggest beach. So think about the biggest beach you can think of and how many grains of sand there are there. Not just on the top, but there's feet of sand, right? A single grain of sand has more atoms in it than all of those grains of sand on the beach. Atoms are really, really small. And this idea that matter is composed of atoms is perhaps one of the greatest discoveries of humankind. Humans spent years, decades, trying to figure out the world around them. Questions like, why does sand stick to everything? And so the idea that matter is composed of tiny particles is a very important idea. To understand how matter behaves, why sand sticks to things, why gasoline burns, etc., we have to understand how the particles that compose the matter behave. And all matter is composed of atoms, atoms and molecules. I want that. So atoms and molecules. Molecules are just groups of atoms that are stuck together, bound together by chemical bonds. We'll talk a lot more about that later. So just as an example, we talked a little about sand. Let's look at water. Here's an illustration of a water molecule. So it contains 3 atoms, 2 hydrogen atoms and 1 oxygen atom, and they're stuck together. We know that water has this sort of a bent structure. What if water was linear? What if the hydrogen atoms were on opposite side of the oxygen atom? Would that affect how water behaves? Yes, it would. It would have a tremendous effect. Water is a liquid at room temperature because of this shape that it has, and we'll learn more about that as well. If water was linear like this, it would behave a lot more like carbon dioxide. Carbon dioxide is a gas at room temperature. And if you, don't want to get into too much detail here. So the shape of the water molecule has a huge impact on the behavior of water as a substance. And so what chemists do is we try to understand the connection between the tiny particles that make up water, that make up carbon, the graphite in your pencil, the DNA that tells your body what color your hair is supposed to be, etc. We look at the connection between atoms and molecules, the tiniest particles of matter, and the everyday world that we experience. So chemistry is the science that tries to understand how matter behaves by studying how atoms and molecules behave. When we understand what's going on at that particle level, then we can do all kinds of cool things with visible amounts of matter.